Today's lesson is lesson 4.3, writing equations in point-slope form. Today's lesson is lesson 4.3, writing equations in point-slope form. Review. The first thing that I want to review with you is slope-intercept form. Remember that slope-intercept form is any equation written in the form y equals mx plus b, where m is your slope and b is your y-intercept. We also need to review standard form. Standard form is any equation written in the form ax plus by equals c, where a, b, and c are integers. Remember that a has to be greater than 0, meaning the leading coefficient needs to be positive, and a, b, and c do not share a common factor. Today, you're going to learn about point-slope form. Now, I want to show you that we're talking about the point, or the ordered pair, given in x, y coordinate, and the slope of a line. So if we know an ordered pair and the slope of a line, we can write an equation in the form of point-slope form. Alright, so today we are going to do a couple of practices. The first thing that we're going to do is write an equation in point-slope form for the line that passes through each point with the given slope. Now remember, all I need to know is the point, -2, 5, and the slope, -6. So I'm going to look at the ordered pair -2, 5, and I'm going to remember that this represents x1. The number -2 represents the x term of the ordered pair, and the number 5 represents the y term of the ordered pair. Alright, I also want to remember that slope is the same thing as m, which is -6. And I just take these values and I plug them into my equation. Y minus, the value for y1 is 5, equals my slope, which is -6, times the quantity x minus x1, which is -2. Now, we typically do not write equations, especially in algebra, as minus a negative. So we are going to rewrite this properly. Y minus 5 equals -6 times the quantity x plus 2. There. Now we have it. All right. For this example, we're given an equation in point-slope form, and we're asked to write it in standard form. Now remember that standard form is ax plus by equals c. So the first thing that we're going to do is we're going to distribute that 7/8 through the parenthesis. We're going to distribute this. Okay? So I have y plus 2 equals, well, 7/8 times x is just 7/8 x. And 7/8 times a -3 is negative. 7 times 3 is 21 over 8, and that cannot be simplified. Okay? Now remember, for standard form, I need to get all the constants on the right. So the first thing that I'm going to do is subtract 7/8 x from both sides. So now I have -7/8 x plus y plus 2 equals -21 over 8. Now I have to move this 2. Okay, so I'm going to do that by subtracting 2 from both sides. So now I have negative 7/8 x plus y equals, well, negative 2 is the same thing as negative 16/8. So I have negative 21/8 minus 16/8. Negative 21/8 minus 16/8, which equals negative 37/8. All right, so I'm going to continue this on the next page. Negative 7/8 x plus y equals negative 37/8. Negative 7/8 x plus y equals negative 37/8. Now the problem with this is that my leading coefficient is not positive and it's not an integer. I need to remember how to get rid of these fractions, and the only way to do that is to multiply every stinking term by 8/1. But that would still leave me with a negative coefficient. So I'm going to multiply everything by negative 8/1. So when I do that, my negative 8 and my negative 8 cancel out, so I have 7x. Negative 8 times y is negative 8y equals negative 8 times negative 8 is a positive 37. Now I have written this in standard form. Okay. All right. Now we're going to write each equation in slope-intercept form. Now again, I have an equation written in point-slope form. Y minus 4 equals 1/2 x minus 7, and I need it to model the equation y equals mx plus b. This one is a little bit easier because I'm allowed to have fractions. So the first thing I'm going to do is distribute this 1/2 through the parenthesis. Y minus 4 equals 1/2 times x is 1/2 x. 1/2 times negative 7 is negative 7/2. All right, I'm going to add 4 to both sides. Adding 4, the whole number, is the same thing as adding 8/2. So this cancels out, and I have y equals 1/2 x. A negative 7/2 and a positive 8/2 is a positive 1/2. This is the equation written in slope-intercept form. That was much easier. All right, lastly, you may be asked to write an equation of a line that passes through 2 points in slope-intercept form. So you still want to model this equation, y minus y1 equals m times the quantity x minus x1. However, you know an ordered pair, you can use either the ordered pair negative 7, 6, or you can use the ordered pair 5, 8. It doesn't matter which one you choose, but you do not know your slope. You don't know m. So that's what we're going to find first. The first thing that we're going to do is find m. And I know that slope is the same thing as y2 minus y1 over x2 minus x1. So I have y2 minus y1 over x2 minus x1. Let's plug in some values for that. y2 is 8 minus y1 is 6 over x2 5 minus a negative 7. Well, minus a negative is the same thing as plus. 8 minus 6 is 2. 5 plus 7 is 12, which is the same thing as 1 over 6. So I know that my slope is 1 over 6. So now I have all the information I need to write my equation. I'm going to choose to use this ordered pair just because I don't want to have to deal with any negatives. So y minus the y1 coordinate, or the y coordinate for my ordered pair, is 8 equals, what is my slope? 1/6 times the quantity x minus the x coordinate of the ordered pair I choose is 5. Now you could have used the other ordered pair. You could have used the ordered pair -7, 6. Let's show you what that would look like. That would be y minus 6 equals, my slope doesn't change, 1/6 times the quantity x minus a -7 is the same thing as plus 7. Okay? Now I bet if you were to put both of these into slope-intercept form, they'd be the exact same equation. But we'll save that for another lesson. Okay, that's it.